The open ocean is an inherently hostile environment. For a commercial vessel carrying thousands of tons of cargo, surviving this constant barrage of kinetic energy requires precise engineering and absolute operational discipline. In the early 20th century, commercial shipping operated without a global safety net. The combination of intense commercial pressure and a lack of universal oversight resulted in catastrophic losses of life, culminating in the sinking of the Titanic in 1912. The international community responded to these mounting tragedies by drafting a single unified treaty, the International Convention for the Safety of Life at Sea, widely known as SOLAS. After decades of technical revisions, the framework matured into the comprehensive 1974 Convention. This text, which officially came into force in 1980 and undergoes continuous amendment, is the active standard governing the waters today. A merchant vessel cannot legally exist in the global supply chain without meeting every technical mandate in the convention. To understand exactly how international law governs the existence of a ship, we can map it directly onto the physical anatomy of a single merchant vessel. The SOLAS Convention is structured into 14 distinct chapters, each mapping onto the physical architecture and operational systems of this hull. These regulations dictate everything from the thickness of the physical steel to the cybersecurity protocols protecting the bridge. Failing to meet the requirements of any single chapter legally paralyzes the vessel, stripping its right to sail in international waters. Maintaining this universal safety baseline creates a predictable standard across millions of square miles of ocean, allowing ships from any flag state to enter any port. Chapter I dictates the general provisions, applying explicitly to passenger and cargo ships over 500 gross tonnage on international voyages. The first tier of legal enforcement belongs to the flag state, responsible for ensuring the vessel holds valid safety construction and equipment certificates. Because structural inspections are highly technical, flag states authorize recognized classification societies to conduct the actual physical surveys of the vessels. If a flag state fails to enforce the rules, the framework relies on a second, more aggressive tier of enforcement, port state control. Port state control allows foreign court authorities to physically board and inspect incoming vessels. If inspectors uncover serious deficiencies, they have the immediate authority to detain the ship at the dock. To guarantee these mechanisms work, Chapter 13 was adopted in 2014. It legally requires the contracting parties themselves to undergo periodic, standardized audits to verify they are actually implementing the rules. This two-tiered, cross-jurisdictional system ensures that vessel owners cannot simply evade the safety baseline by registering their fleet in a lenient country. Moving from the hull up to the bridge, we reach the ship's external awareness network. Chapter 4 governs all radio communications on board and mandates the implementation of the Global Maritime Distress and Safety System. Historically, a ship's ability to call for help was limited by atmospheric conditions and range. Under Chapter 4, ships must utilize integrated satellite and terrestrial radio services, guaranteeing they can send and receive distress signals anywhere on the planet. While Chapter 4 handles communication, Chapter 5 dictates the physical tools and procedures required for the safety of navigation. Unlike the tonnage threshold of Chapter 1, Chapter 5 contains a critical jurisdictional distinction. Its rules apply to all seagoing vessels of all sizes. This nautical chart represents a fraction of the mandatory publications required under Chapter 5. Ships must conduct precise voyage planning and carry specialized equipment, including voyage data recorders and automatic identification systems, to continuously broadcast their position. Chapters 4 and 5 ensure a ship's position and distress signals are continuously accessible, ending the era where a vessel could disappear silently into the void. Beneath the bridge, the SOLAS framework directly targets the payload. Chapter 6 governs the carriage of cargoes. It establishes strict mathematical requirements for safe loading, securing, and stowing to ensure the vessel maintains its center of gravity. Transporting bulk cargo, like loose grain or iron ore, presents a severe risk. If tons of material shift during heavy weather, the entire vessel can rapidly capsize. To mitigate this, SOLAS mandates compliance with the International Maritime Solid Bulk Cargoes Code. When that payload is volatile, Chapter 7 takes jurisdiction over the carriage of dangerous goods. It mandates adherence to the IMDG code, which standardizes exactly how toxic, flammable, or explosive materials must be packaged, labeled, and physically separated from other cargo. For the massive vessels designed specifically to transport these payloads, the convention includes Chapter 12. This chapter applies exclusively to bulk carriers over 150 meters in length, enforcing extreme additional safety requirements to counteract the unique torsional stresses placed on their elongated frames. The payload chapters treat the cargo itself as an active physical threat, forcing operators to prioritize structural stability over maximizing commercial volume. Standard cargo ships make up the majority of the fleet, but the SOLAS framework is highly adaptable to non-standard marine architecture. Chapter 8 governs the unique engineering requirements of nuclear ships. Because a nuclear propulsion system introduces severe radiation and reactor containment risks, Chapter 8 creates a bespoke code of safety that is entirely separate from the rules governing standard diesel engines. Similarly, Chapter 10 establishes the safety measures specifically designed for high-speed craft. These specialized vessels operate under entirely different hydrodynamic pressures and face high-velocity impact risks that traditional displacement hulls do not, requiring a completely separate set of physical limitations. By utilizing this modular structure, SOLAS provides strict regulatory sandboxes. It accommodates extreme, cutting-edge engineering without relaxing the global baseline for standard vessels. The convention also dictates internal protocols for human operations and corporate management. Chapter 9 mandates the International Safety Management Code for ship owners and operators. The ISM code operates on a simple philosophy. Safety must be a documented, fiercely enforced organizational culture, originating from corporate management, not just a hard-right checklist for the crew. Transitioning from internal management to external threats, Chapter 11-2 outlines special measures to enhance maritime security. Following the 2001 terrorist attacks on the United States, the International Ship and Port Facility Security Code was instituted as a rapid, direct legal response to secure the global supply chain. The ISPS code forces vessels and port facilities to implement mandatory ship security plans and designate trained ship security officers to defend against hostile boarding or sabotage. The most recent frontier of maritime regulation sits in Chapter 14, the Polar Code. Any ship intending to operate in extreme Arctic and Antarctic waters must now meet rigorous, heightened standards for physical ice strengthening and crew thermal survival. From terrorism to extreme climates, these modern chapters prove that SOLAS is a living document, actively evolving to regulate human behavior and external global threats. Zooming out from a single hull, we can observe the sheer scale of this regulatory framework. SOLAS operates as an inescapable legal net, binding every commercial participant that moves through international waters. If a ship fails its Chapter 1 structural survey, mismanages its Chapter 6 cargo stability, or lacks a Chapter 11 security plan, it is detained. And the treaty continues to expand. The 2010 amendments introduced goal-based ship construction standards, shifting the legal focus from simply checking boxes to achieving proactive, performance-based engineering. Today, ongoing updates are actively integrating regulations for automated navigation, digital cybersecurity, and the necessary push for maritime decarbonization. The mathematical and legal rigor of SOLAS provides the technical certainty required for global trade to transit the high seas. Establishing these universally enforced standards remains the only way to sustain safe commercial passage across the globe.